Hello children, you are joining with Gedara educational program. Welcome back to our science lesson Simple Machines part 2. At the beginning of our lesson, we have a little bit challenge. The challenge is lifting this weight upon this stage. Yes, I could lift this up and put it on this stage, but we are going to use science today. We are going to use simple machines to make this work easier. My simple machine is this. Yes, actually it doesn't really looks like a simple machine. It doesn't really looks like a simple machine, but this is going to make our work easier. As you thought, if I lift this object up to this stage, I should exert a force. I will measure that force using the spring balance. Now, I am fixing the load to the spring balance. Spring balance is necessary to measure the force that I exerted, and I am lifting it up. And take a look at this. It weighs 3 Newton. That means I am exerting 3 Newton force to lift this load up and put it on this table. Now, let us look what will happen if we use this inclined plane to load this, to lift this object onto this stage. For that, I am using the same spring balance and I am pulling the load along this simple machine. Okay, I am pulling it up and have a close look at the reading. It's 1.5 Newton, about 1.5 Newton, and I am pulling it along this plane and I can put it on this stage. So, you could say that by using this, the force exerted to lift this load could reduce. Earlier, when I lifting it up, straight up, it took 3 Newton, but when I pulling this along this plane, it took 1.5 Newton. So, you could see that this machine makes our work easier. What is this machine? Inclined plane. What is inclined plane? Plane is a flat surface. Inclined means slope. When I increase one side of the flat surface, it becomes an inclined plane. So, this makes our day-to-day work easier. Now, let us see what happens to the force that we exerted to lift the load along the inclined plane when the inclination changed. Now, I will increase the inclination like this. Now, you can see clearly the inclination has increased, and as earlier I am going to lift this using this inclined plane and have a close look at the scale. It's about 2 Newton. I am pulling it along the inclined plane, and it is taking 2 Newton. Now, what happened? Earlier, when the inclination is lower, the force was about 1.5 Newton. When I increase the inclination, the force that I should exerted increased. Now, I will show you what happens when the inclination decreases more. I will use the same spring balance and the load. When I am lifting this along this inclined plane, the Newton balance reading is about 1 Newton. Now, what happened? When the inclination decreases, the force I exerted also decreases. So, it is clear now. When the inclination is higher, the force exerted is higher, and when inclination is lower, the force exerted is lower. So, the force that we exerted can change by changing the inclination of the inclined plane. Now, let us go to the calculations about inclined plane. First thing, mechanical advantage. I think you can remember in the earlier lesson I discussed about calculations, and most important one is mechanical advantage. It gives the number of times that the force increased by the machine. We can calculate it using the equation load over effort. Look at this diagram. It shows an inclined plane. The object weighs 750 Newton and the force exerted to lift it 250. So, load is 750, effort is 250. Answer 3. That means this inclined plane increases the effort 3 times when lifting this load. So, it is clear that from the mathematical calculations also, simple machine increase the day-to-day work easier. The second calculation, velocity ratio. You know, velocity ratio is the displacement of effort over displacement of load. What is the displacement of effort? That means the distance that we exert the force, that is equal to the length of the inclined plane, that is 4 meter. And what is the distance moved by the load? Earlier the load was in the ground level and finally it is up. The perpendicular distance is 1 meter. So, velocity ratio can be calculated using this 4 upon 1 meter, and finally the answer is 4. You know, as well as mechanical advantage and velocity ratio has no units. It's a ratio. Third calculation, efficiency of the machine. Think you can remember, this was also discussed in the earlier lesson. Efficiency of the inclined plane can be calculated by mechanical advantage over velocity ratio equation. Can you remember? Mechanical advantage we calculated and obtained the answer 3, and velocity ratio the answer 4. 3 upon 4 multiplied by 100, because efficiency is a percentage, and you can get the answer as 75%. Next, work input and work output. Work input, the work done on the machine. You know, work input can be calculated effort into distance travelled by the effort. Effort is 250 Newton and distance is 4 meter, 1000 joule. Work done on the machine or work input is 1000 joule. Work output, work done by the machine, that is the work done by the machine is 750 Newton raised to 1 meter. So, 750 into 1 meter, that is 750 joule. Work done by the machine is 750 joule. Can you remember, children? Last day I told you another way of calculating the efficiency of machine. Look, that is efficiency calculation by work input and work output. Remember, work output divided by work input into 100% can be used to calculate the efficiency of the inclined plane. In this way also you will get the same answer, 75%. So, what are the day-to-day applications of inclined planes? We can see inclined planes in everywhere: wedge, staircase, screw jack, screw nail and ladder. We see the wedge, we use normally wedges to split logs of wood. When the force exerted, it is split into two and exerted on the either sides. So, the work makes easier, and I can show you another example. Here we can see the nail, tip of the nail, and it is a inclined plane, and another nail, the tip is flat. Which is easier to fix into a wood? Definitely your answer is this. Why? There is a inclined plane at the tip of the nail. So, it is also a inclined plane. Staircase, ladder, we use ladder to climb up to a high elevation, and screw jack and screw nail. Screw nail, you will wonder whether screw nail has a inclined plane. Yes, I will show you that. Can you identify this shape? It is an inclined plane. You can see the blue line upon this shape. It is an inclined plane. Now, I am going to wind this around this. Let us pretend that as a nail. See, look what will happen. Look at the blue line. It is the similar shape as screw nail. The inclined plane has wound around the nail, and the shape is very similar to the screw nail. So, screw nail is nothing but an inclined plane which wound around a metal rod. So, what are the other instances we can see? We can identify inclined planes. In the kitchen, we have many inclined planes: knife, fork, cheese grater, and everywhere around us we can see inclined planes. So, now you studied inclined planes make our work easier. Not only inclined planes, there are more simple machines. I am going to show you another simple machine, wheel and axle. So, wheel and axle used in many instances And what is wheel and axle? I took a toy, part of a toy, and you know this very well. It is a wheel and a metal rod. We can call this as an axle. If I fix this to the wheel, what is it now? It is a wheel and axle. So, wheel and axle simple machine has a larger wheel and a small rod which is called axle, and both fixed together. When we apply a force to wheel, the axle also rotates, and we call this simple machine as wheel and axle. Wheel and axle is very common in windlass. I think you have know about windlass. I have a small structure of windlass. It has a large wheel and a small axle. Normally in windlass, we used to lift loads from lower levels to up, and therefore, the axle is connected to a thread, and at the end of the thread or rope there is the load that should be raised up. So, I will show you how windlass works. When the force is exerted to the wheel rotates, and the force transferred to the axle, and axle rotates. You could say when the axle rotates, the rope or thread which is going around the axle wound around it. Therefore, the length of the thread or rope decreases and weight lifted. So, this is the structure of windlass. Now, let us see calculations related to wheel and axle. Mechanical advantage, as the other machines, the first calculation is mechanical advantage, that is load over effort. Here the load and effort is equal because we exert the force to lift the weight, and same force we exerted to lift the load. But if there is friction, a little bit greater force that we exerted to the machine is little bit greater than load. But if we assume that the friction of the machine is 0 or negligible, mechanical advantage is load over effort. So, load is the weight of this object and effort is the force that we exerted here. So, when we calculate mechanical advantage, both are same. So, answer is 1. So, normally for windlass, mechanical advantage equals 1. Velocity ratio. You know, velocity ratio is displacement of the effort over displacement of the load. What is displacement of effort? That is the distance that we exert the force. Now, let us assume this place I am going to exert the force and load is there, it is going to be lifted. So, carefully take a close look at this. I am exerting the force on wheel and it rotates once. What is the distance moved by the effort? It is equals to the circumference of the wheel. Circumference of the wheel. Mathematically, you know what is how to calculate circumference. The mathematical equation is 2 phi r. Circumference of a circle equals 2 phi r. What is r? R is the radius, distance between center and circumference. Let us assume circumference of this wheel is 2 phi r and radius of this wheel is capital R. Then what is the displacement of the effort? that is 2 phi r, capital R. When I exert the force once, the axle also rotates once. So, then the thread wound around the axle once and length of the thread decreases to distance equal to the circumference of the axle, and weight raised a distance which is equal to the circumference of the axle. Think you can understand that. So, how to calculate the circumference of axle? That is also same equation we can use for calculating the circumference of the axle. The mathematical equation is 2 phi r. Let us assume radius is simple r. So, circumference of the axle is 2 phi simple r. So, velocity ratio can be calculated using those two values: circumference of the circle of the wheel and circumference of the axle. 2 phi capital R over 2 phi simple r. 2 phi can be cancelled out and velocity ratio is capital R over simple r, and velocity ratio can be calculated radius of the wheel over radius of the axle. Again, where we use this simple machine, wheel and axle. You are familiar with this equipment. To loose and unloose the nuts and bolts connected to a wheel, and this is the wheel and this is the axle. The force is exerted to the wheel, and screwdriver. It is also another example for wheel and axle. Here is the wheel, the handle is the wheel, larger circumference, and the point is the axle. So, this can be used to fix and unloose screw nails. And my toy, I fix it again to another wheel. What is it? You are familiar with this. This change the transportation in our world. You can see here in the car, skateboards, bicycle. In all of these equipments, we use wheel and axle. So, look at around you, there are wheels and axles at work. Okay children, now we studied about two simple machines, inclined planes and wheel and axle. Now, I am going to introduce you another simple machine. It is pulley. What is a pulley? Pulley is again wheel which can rotate around its own axis. And children, look at this. It has a groove, and along this groove a rope wound, and I will explain you how to use this and why we use a pulley. We use pulleys to lift loads, or sometimes change the magnitude of the force that used to lift the load, and change the direction also. So, let us look at how to use a pulley to make our day-to-day work easier. So, same way I had the load and I am going to lift this. Now, if I lift this using the spring balance, it is about 3 Newton. Now, I use a pulley to lift this, and I fix it to the pulley slowly. And children, now I am going to lift the load using the pulley, and take a close look at the reading. That is about 2.7 Newton, about 2.5 Newton. So, is it making our work easier? Earlier I also told you this is about 2.5 Newton weight, and now the reading says, reading of the spring balance also says it is 2.5 Newton force to lift this load. Actually, it does not reduce the magnitude of the force, but now I am exerting the force downwards. You can see, to lift the load I am exerting the force downwards. It is much easier than exerting the force upwards. Exerting a force upwards is little bit difficult, but exerting a force downwards is easier. So, using a single pulley we can change the direction of force that we exerted to lift the load. So, that way we can make the simple machine to make our day-to-day work easier. You saw that using one pulley the effort does not decrease. That means, the force that we exerted to do the work does not decrease, but it makes the work easier by changing the direction. So, pulleys can be used to change the direction or decrease the magnitude of the force. You saw that using one pulley the effort does not decrease, but it changed the direction of the force. So, simple machine called pulley can be used to change the direction of the force as well as decrease the magnitude. So, how do we decrease the magnitude of the force that we exerted to the machine? We can use the single pulley in a different way to decrease the force, as well as we can use more than one pulley to decrease the force. Now, I will show you how to use two pulleys to decrease the force that we exerted to lift the load. This is the second pulley I used, and I fixed the load to the second pulley, and this is the spring balance. I used this to measure the force that I exerted, and I fixed the rope to the second pulley, and slowly I am winding this thread around the first pulley. Now, you can see a pulley system. The load is fixed to the second pulley and the first pulley is fixed to a stand, and I am pulling this rope from this end, and you can have a close look at this scale, and it is about 1 Newton. Can you remember the weight of this load? It was about 2.5 Newton. Now, the scale says the force I exerted to lift this is about 1 Newton. This is the way that I am pulling the force and lift the load. So, I will remove it slowly. So, children, when we use two pulleys, the force that I exerted to lift the load was decreased. So, we can use two pulleys to decrease the effort. If we use 3 pulleys, will you think the force decreases more? Yes, we can use more and more pulleys to decrease the effort that exerted to lift a load, but it is a little bit complex. Now, let us go to the calculations of pulleys. Same way, we can calculate the mechanical advantage, and I think you can remember the load that we lifted is this, and it was about 2.5 Newton, and the force I exerted by using a single pulley also was 2.5 Newton. That means load and effort is equal when we use a single pulley. Now, same example, an instance where we use a single pulley. Here the load is 550 Newton. The calculation is weight of a bucket full of water is 50 Newton and it is lifted up using a pulley. Assume that this sentence is very important. Assume that the pulley has no friction. That means when the pulley rotates around its own axis, there is no friction. It smoothly move around the axle. So, in that instances, load is equal to the effort that we use to lift the load. So, clearly you can see that answer is 1. So, as I have told you earlier, single pulley does not decrease the force that we exert to do the work. And I need to tell you something about the travel distance moved by the load and distance moved by the effort. I am going to show you that. Now, look at the distance moved by the load. Now, if let us assume I am moving the force effort to about 20 centimeter, or I think it is 10 centimeter, then the load lifted to equal distance 10 centimeter. So, when we use a single pulley, distance moved by the load and distance moved by the effort are equal. So, the velocity ratio also equal. So, calculations regarding one pulley, the examples for one pulley, it is easier to calculate mechanical advantage and velocity ratio. Now, let us see the next calculation regarding pulleys, that is work input and work output. As mechanical advantage is 1 and velocity ratio also 1. So, we can calculate now work input and work output. What is work input? I think you can remember work input is the work done on the machine, that is 50 Newton, and in the earlier diagram we raised it by 0.8 meter, that means 80 centimeter, and you know how to calculate work, force into the distance moved by the force, and for that instance that is 40 joules. The work done on the machine is 40 joules. Next calculation, work output, work done by the machine, that is load and displacement of the load. I showed you the displacement moved by the load is equal to the displacement moved by the effort. So, that is all. So, same. Now, let us say work output, that is load into displacement travelled by the load, the same distance and same work output. So, when we use single pulley, work input and work output is equal. So, therefore, the efficiency of the pulley is 100%. Remember, at the beginning of the question I told you friction of the pulley is 0. So, when the friction is 0, the efficiency of the pulley is 100%. Now, for my next example, next activity, calculating mechanical advantage, velocity ratio and efficiency when we use 2 pulleys. This we have to think little bit. Here we lift 80 Newton weight and we use 40 Newton force. Think you can remember when I showed you when we use 2 pulleys, the effort decreased. Same way in our example also, force that we exerted to lift this load is less than the force. Think that occurs because we use 2 turns, weight of the load divides into 2 and force exerted along one thread is half of the weight of the load. So, that is why the force exerted, final effort becomes 40 Newton, half of the weight of the load. And next thing, displacement. If I exert this, if I pull this thread 2 meters away, the load raised 1 meter. Can you understand that? Because there are 2 threads. When I pull this thread 2 meters out, the thread should pull up another 2 meter. But as there is 2 threads, one thread raised by 1 meter and finally the total becomes 2 meter. So, the load raised 1 meter. So, displacement, now let us go to the beginning. Mechanical advantage, the load is 80 Newton and effort is 40 Newton. Mechanical advantage equals 2. That means, when we use 2 pulleys, force exerted to the machine increased twice. And let us go to velocity ratio. Displacement of the effort 2 meters, displacement of the load 1 meter, and final answer is 2. The efficiency of the machine, mechanical advantage over velocity ratio multiplied by 100 because it is a percentage, and you know both answers, it is 2 and efficiency is 100%. So, you should be able to calculate same calculations. If we use 3 pulleys, what will happen? You can try this. 100 Newton weight lifting by a 25 Newton. That is what happening when we increase the number of pulleys. When we add more and more pulleys, the force exerted decreases more and more. So, here I lift 100 Newton force weight by applying 25 Newton effort, and when I pull this thread to 1 meter distance, the load raised only a 25 meter distance. That happens because number of threads are increased. Number of threads are larger than earlier. When I pull this 1 meter, load will raise only 25 centimeter, but the magnitude, look at the magnitude of the force, it is 25 to lift 100 Newton weight. So, try this, take a pencil and a paper, sketch this diagram, and this is a homework. Calculate mechanical advantage, velocity ratio and efficiency for this pulley system. Okay, I will keep it, and let us discuss what are the examples that we can find, say, pulleys in our day-to-day activities. I think you have finished. Flagpoles. In the flagpole, at the top of the flagpole there is a pulley, and when we pull the thread, the flag goes up to the top of the flagpole. And even in cranes, as I told you, there are large number of pulleys to make the work easier. Here you can see there are lots of pulleys and lots of threads which wound around them. So, this little bit complex, but the load can be decreased in a great extent. As well as in cranes, in boats also there are, we use, fishermen use pulleys and pulley systems. And even inside the engine of the car, there are pulley systems. Okay children, we studied about simple machines and they are all around us. So, go to the kitchen, you can find large number of simple machines belongs to each category: levers, inclined planes, wheel and axle and pulley. And all around us, when you go to the road, there are vehicles, in vehicles different types of simple machines can be seen, identified. So, you know, at the beginning also I told, complex machine is a collection of simple machines, and in the bathroom also you can see different types of simple machines in work. So, you go to your surrounding, observe your surrounding and identify the simple machines you can see and categorize them and make a list of simple machines. So, children, we have come to the end of our lesson. Hope you enjoyed and studied much more things about science and simple machines. So, children, finally I wanted to tell you that do your studies well and do your hobbies and stay safe. Goodbye children.